Okay, good morning. Welcome back to trigonometry. We are going to go ahead and graph y equals -2 cosecant pi x minus pi over 12. This is going to be kind of a tough one because there's a lot of pi's in here, and that's usually a problem. If there's one pi in it, it's usually easy. If there's two pi's, then it's going to get a little bit rough. I'll show you what I mean by that. So cosecant is the reciprocal function of sine. If I'm graphing sine, and I'm going to have to, what the what I would want to do for a parent function for sine is I would like to graph 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the functions, those are the things I'd really like to graph. That makes my graphing sine really easy. So what I'm asking here is, what does x have to be so that pi x minus pi over 12 is equal to 0? What's x have to be for this to happen? So we're going to go ahead. We'll start with the 0 because that's the easiest one. And we'll do, this is pi x, add pi over 12 to both sides. So we have equal to pi over 12. And then we're going to divide both sides by pi or multiply by 1 over pi on both sides, right? And we'll get x equals 1 over 12. Okay, hold that thought, all right? So that's my first little thought there. That's my first number. You don't have to do them in order. And in this case, I'm not going to do them in order. I'm going to skip around to the pi and the 2 pi and then come back and fill the ones that I missed. So the next one I want to deal with is pi x minus pi over 12 is equal to pi. What does x have to be for this to be true? So we have pi x equals pi plus pi over 12. And here we have to get common denominators, right? So we have 12 pi over 12 plus 1 pi over 12. So we'll have pi x equals 12 plus 1 is 13 pi all over 12. Okay. Now, the last thing we're going to do is we're going to divide both sides by pi. So we're going to say x equals 13 twelfths. Okay. We just multiply by 1 over pi on both sides. That cancels my pi. Okay. The next part of this problem, we're going to say pi x minus pi over 12 is equal to 2 pi. And we'll go ahead and solve this piece. So we have pi x equals 2 pi plus pi over 12. And again, I'd like to get common denominators, so I'm going to multiply by 12 over 12 here. So we're going to have 24 over 12 pi plus 1 pi over 12. That's going to be 12 plus 1. Sorry, it's going to be, yeah, it's going to be 24 plus 1. So I have pi x equals 24 plus 1 is 25 pi over 12. We're going to multiply it by 1 over pi on both sides, 1 over pi on both sides. So I get x equals 25 over 12. Okay, great. Now let's go ahead. We're not quite done yet because we still have 2 more points to deal with, and we'll go ahead and figure that out. So we have pi x minus pi over 12 is equal to pi over 2. Let's go ahead and add the pi over 12 to both sides. We have pi x equals, and here I have pi over 12 plus pi over 2. Let's go ahead and get a common denominator. So let's go with 6 over 6. So I've got 6 pi over 12 plus 1 pi over 12. We have pi x equals 6 plus 1 is 7 pi over 12. And then we're going to divide both sides by pi, and we're going to end up with x equals, right? We divide 1 over pi or multiply 1 over pi on both sides to get 7 over 12. Okay, this turns out to be nicer than I thought it was going to be. All right. Next one up, we're going to say we have pi x minus pi over 12 is equal to 3 pi over 2. So let's go ahead and add pi over 12 to both sides. So we have pi x equals, and here we have 3 pi over 2 plus pi over 12. And again, we're going to go ahead and we're going to say we need a common denominator. So I'm going to multiply 6 over 6. So here we have 18 pi over 12 plus 1 pi over 12. That's going to be pi x is equal to 19 pi over 12. Let's go ahead and multiply by 1 over pi on both sides, 1 over pi on both sides. So we end up with x is equal to 19 over 12. All right. Now, as I'm looking at my numbers here, I have 1 over 12, 7 over 12, 13 over 12. It looks like I'm adding 6 over 12. What's going on here? 13 plus 6 is going to be 19. 19 plus 6. Hey, this makes a pattern. I knew you would see that. Okay, so as I'm going through to graph this thing, I've got enough information to graph my sine, so we're going to start with that first. Okay, So we'll go ahead and draw our sine out first here. All right. So what do we have here? We have -2 cosecant. So I've got to go ahead and deal with 1, 2, 1, 2. So we're going to say, okay, normally I would start my sine this way, but actually it's going to be reflected. So we're going to go, here is my 1 over 12. Here is my 25 over 12. And my middle here, we're going to say this is 13 over 12. Okay. And then we're going to have what's over here is a 19 over 12. 19 over 12. And I believe here we're going to have a 7 over 12. Okay. Now, normally we want to graph our sine. I'm just going to dot it in first. We're going to be down here, 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 up here, and then back down here again. So I'm graphing a reflected sine in order to be able to graph a reflected cosecant. Okay. Now, we know where our zeros are. We're going to go ahead and we're going to replace our zeros with asymptotes. We did that in red. Okay, and now it's time to actually draw in my sine. We'll go back to blue, I suppose, for graphing in our sine here, or for our cosecant rather. So I'm going to have a cosecant type of a thing going on right here. Okay, and then we're going to have a cosecant piece sitting over here. Okay, so this would be my graph of cosecant. We have a 2, we have a -2, and we're looking for this kind of reflected value here. But that's how you go ahead and graph, this kind of a function, a cosecant function. You graph the reciprocal function first, and then you dot that in, say where the asymptotes are. And again, you could have said, okay, we are going to go ahead and say this is going to be point A, B, C, D, and E, and gone through and said what's going to happen here. We've got relative maximums, right? So relative, it's as far as the neighborhood of what these points are, this is the biggest one. We have a relative minimum. As far as the neighborhood of points here, this is the smallest one. Okay, so it's a relative minimum. It's not the absolute minimum. There's points that are smaller down here. Okay. And again, this is not the absolute maximum. There's points that are bigger over here. Okay, but it's relative to the points around it, the biggest or the smallest points. And of course, we have our asymptotes. Okay, so thank you very much for watching. I hope you do well with graphing those kinds of problems, and I will see you in the next video. Thanks.